It is a curious thought. The Sahara Desert, that vast ocean of sand, was not always so. Only a few thousand years ago, a mere blink in geological time, it was a green and vibrant land. Rivers flowed where there is now only dust. Hippos and crocodiles thrived in deep lakes. This remarkable transformation is not a myth. It is a secret whispered by the earth itself, a profound reminder that our world is not static. It is a place of constant, powerful, and sometimes bewildering change. The ground beneath our feet is not a fixed stage but a dynamic actor, forever rewriting its own story through wind, water, ice, and fire. This planet is alive. Imagine the Earth as a magnificent, self-regulating machine. Deep within, its molten iron core acts as a giant furnace generating immense heat. This heat must escape. It rises through the planet's mantle in slow, powerful currents. These currents are the great conveyor belts of our world, the engine of our planet, plate tectonics. This internal engine has a partner, the sun. Our star bathes the planet in energy, but this warmth is not distributed evenly, creating a fundamental imbalance. Nature tries to correct this, setting the atmosphere and oceans in motion. This constant circulation is the genesis of our weather, a breathtakingly complex symphony. The planet has kept a diary written in stone. Every layer of sedimentary rock is a page from this diary, capturing snapshots of forgotten worlds. Geologists can look at a towering cliff face and see a story unfold. Ancient deserts, rising seas, warm oceans teeming with life. One profound story is Snowball Earth. 700 million years ago, geological evidence suggests our planet froze almost entirely, a world encased in ice. The rocks record the air itself. These formations show when early life began pumping oxygen into the atmosphere, creating the breathable air we depend on today. The great ice sheets are Earth's most pristine library. Each year adds a new layer, trapping tiny bubbles of ancient atmosphere, perfect samples preserved for hundreds of thousands of years. By drilling deep and extracting ice cores, we can travel back in time, layer by layer, season by season, a frozen chronicle of our planet's climate. Projects like Epica have been revolutionary, showing that for 800,000 years, atmospheric carbon dioxide fluctuated between 180 and 280 parts per million, moving with ice ages. When temperature records are laid next to greenhouse gas records, the correlation is astonishing, demonstrating the powerful link between greenhouse gases and planetary temperature. Few phenomena are as dramatic as the supercell thunderstorm. This is a meteorological beast, a single, vast, rotating updraft called a mesocyclone, king of thunderstorms. A supercell requires a volatile recipe, abundant moisture from warm water, atmospheric instability, and wind shear that twists the rising air column, setting it spinning like a top. Once formed, the supercell becomes a self-sustaining engine. Its rotation separates updraft from downdraft, allowing it to persist for hours and travel hundreds of miles. These storms are most common in Tornado Alley, where unique geography brings all ingredients together, a perfect breeding ground for atmospheric monsters. If a supercell is focused violence, a hurricane is a sprawling engine of chaos, the largest storms on Earth born over warm tropical oceans where water exceeds 80 degrees Fahrenheit. A hurricane is a giant heat engine. Warm, moist air rises and condenses, releasing tremendous heat, creating a powerful positive feedback loop that intensifies the storm with breathtaking speed. The storm's spiral shape and calm eye result from Earth's rotation. The Coriolis effect deflects inflowing air, creating the iconic spiral and tranquil eye surrounded by the most ferocious winds on the planet. A single mature hurricane releases energy equivalent to 10,000 nuclear bombs, a profound demonstration of Earth's ability to move energy and the vulnerability of those in their path. Our most comprehensive understanding comes from silent sentinels orbiting above, a constellation of Earth-observing satellites acting as planetary guardians, continuously monitoring our world's health. Ghost satellites remain fixed over the equator, providing familiar satellite loops on evening news, tracking clouds and hurricanes in real time with images every 30 seconds. The Jason series measures sea surface height with millimeter precision, revealing ocean hills and valleys caused by currents and identifying warm water pools that rapidly intensify hurricanes. Missions like Aqua, Terra, and Grace provide undeniable global evidence of our changing climate, moving Earth study from local observations to truly global science. Our planet remains deeply mysterious. We know more about Mars than our ocean floors. Deep Earth processes, subsurface life, and precise mantle mechanics are active research areas. Climate feedback loops remain sources of intense study. Clouds cool by reflecting sunlight but warm by trapping heat. Tipping points for ice sheets and rainforests are not yet known. We are now co-authoring Earth's story. Our knowledge has given us profound understanding of the delicate balance making this world habitable and grave responsibility. The journey continues, driven by curiosity. More secrets await revelation, more storms to understand, more mysteries to solve. In seeking to understand our planet, we may better understand ourselves.